Okay, we're going to solve this problem, task 3, page 74. We have a heap of grain and it's shaped like a cone. A D, C, and F. And the first question is to find the angle between AF and the base of the cone. So basically this angle here. So we can draw out that triangle A, C, and F. And we know the height of the cone, it's 5 meters. The radius is 2. This is a right angle. So we can use tangent here. So tangent to A, or rather, oh, this is not C, this is O. Tangent to OAF is 5 divided by 2. So angle OAF is the inverse tangent to 5,2, or 68.2 degrees. Okay, that's the first task. Let's look at the second. That's B, the slant height. And slant height, what does that mean? Well, it's not simply the height, obviously, so it has to mean something else. So it's this distance along the side here. So this is the slant height. Now we can find the slant height by, let's see, if we have the center of the cone down here. We know the height of the pile, and we know the radius. And here we can simply use Pythagoras. So if this is x, then x equals square root of 5 squared plus 2 squared, which is the square root of 29, or approximately 5.39 meters. Now, C is a little bit more complicated. So I'm going to draw a sketch here, because this is the point A on the sketch. The cone actually goes like this. So this is the outside edge of the cone. And this is the point C, and this is the point F. And we're asked to find the angle between AF and CF. So this angle here. Now this is a triangle. It's not a right triangle. We've already found the length of AF. That was the slant height. Or it's the same as the slant height. So that's going to be the square root of 29. So this is also the square root of 29. And what else do we have? We know that, okay, this is the base called O. There's one more piece of information in the task which isn't drawn on the sketch in the book, and that is the angle here. it says that A and C are points on the circumference, on the circular base of the cone, and the angle AOC is 120 degrees. Oh, sorry. Now, this is a solution for this triangle. You know, hang on, no, you want to solve for this triangle first. And you know the sides here, that's the radius. And then you can find this side here. So this is really AC, right? Equals 2 squared plus 2 squared minus 2 times 2 times 2 multiplied with cosine to 120 degrees. And that should be squared, yeah? Then you can take the square root of everything here. So that gives you AC equals square root of 4 plus 4 minus 8 multiplied with cosine 220, which is negative 0.5. So AC equals square root of 8 minus 8 multiplied with negative 1/2, so that's going to be 4 minus, so 8 plus 4. So AC equals square root of 12. So this is the square root of 12. And then we can use the cosine rule again. To solve this triangle. So this is the angle we want to find. And now we don't know the angle, but we know all the sides. So that means that square root of 12 to the power of 2 equals square root of 29 squared plus square root of 29 squared minus 2 times square root of 29 multiplied with square root of 29 multiplied with cosine to AFC, which is this angle here. Square root of 12 squared is just 12, and this is just 29 plus 29 minus 2 times 29, because square root of 29 multiplied with square root of 29 is 29. And then cosine to angle AFC. We can move things around to isolate the angle. 12 minus 29 times 2 divided by negative 2 times 29 equals cosine to AFC. Which means that angle AFC equals the inverse cosine to, let's see, 12 minus 29 times 2, that's minus 46 divided by minus 58. And if you punch that into the calculator, you'll get 37.5 degrees.